Okay, so here's another trig equation. This time we have secant, and our period isn't changed, but our whole function has been, trig function has been shifted to the right a little bit. So first thing I'm going to do is I'm just going to change secant into cosine of theta minus pi over 6. So I'm going to flip this and get negative 1 over radical 2. And hopefully you recognize that 1 over radical 2, if I rationalize the denominator, this is the only time I feel it's appropriate to rationalize the denominator, I get radical 2 over 2. So therefore we're looking for when the cosine of theta minus pi over 6 equals negative radical 2 over 2. So again, I'm just going to let this equal w. So I'm going to say cosine of w equals negative radical 2 over 2, where w is equal to theta minus pi over 6. And so I'm going to just find the critical values that I need when cosine is equal to negative radical 2 over 2, and then I'm just going to solve this simple equation. So cosine equals radical 2 over 2 of pi over 4, but we want it to be in the second and third quadrant because that's when cosine is negative. So w is equal to 3 pi quarters and 5 pi quarters. But we've already said that w is equal to theta minus pi over 6. So how would you solve this simple equation? You would just add pi over 6 to both sides. So therefore I have to add 3/4 plus pi over 6 and 5 pi fourths plus pi over 6. So in order to handle this, we got to change everything into common denominators of twelfths. So let's just do this over here. Change this into twelfths and multiply by 3. So that's 9 pi twelfths. And this one I multiply by 3, I get 15 pi twelfths. And I'm adding pi over 6, which is the same as 2 pi twelfths. So I add that, I get 11 pi twelfths and 17 pi twelfths. Notice that I added pi over 6, so that could make one of our angles go outside of our acceptable region from 0 to 2 pi. So in terms of twelfths, 2 pi is 24 twelfths pi. Both of those are less than 24 pi twelfths. So therefore, those are our solutions to this trig equation. Okay, so here we have cosine equals negative 1. Again, we have kind of an ugly statement here. So we'll deal with that later. We'll just set up a simple equation with the trig angles that we get when cosine equals negative 1. So we're just going to let w equal 2 theta minus pi over 2. So therefore, cosine equals negative 1 at pi, so w is equal to pi, but we know w is equal to this expression here. So 2 theta minus pi over 2 is equal to is equal to pi. However, keep in mind, since my period has been adjusted, we want to add 2 pi to pi. So therefore, we're going to add 2 pi to that. And since this shifts my function to the right a little bit, I'm going to add another 2 pi. So therefore, I did that wrong. I can't do simple math. That's 3 pi and that's 5 pi. So I'm going to solve this simple equation with 3 pi and 5 pi. So the reason I did another 2 pi is because this whole function got moved to the right. So I want to make sure that I get all the appropriate values. I also might want to consider the negative direction on this. I also want to subtract 2 pi. So that would be negative pi. Because since my whole graph got shifted to the right, and since I'm adding pi over 2 when I solve this equation, I might end up, this might end up being a possible solution after I'd solve this equation. It might be between 0 and 2 pi. So I'm going to add pi over 2. So to add pi over 2, this is equal to 2 over 2 pi. This is 6 over 2 pi, 10 over 2 pi, and negative 2 over 2 pi. And I'm adding pi over 2, so that's 1/2. So I get 3/2 pi, 7/2 pi, sorry about that, 11/2 pi, and adding one more gives me negative pi over 2. And now I have 2 theta left over, so that means I need to divide all of these by 2. where's my pen? Divide all of them by 2. The same thing as multiplying by a half. So therefore I'm just going to write my answers up here. So 3/2 times 1/2 is 3/4 pi. That's 7/4 pi. That's 11/4 pi. Oops. And that's negative pi over 4. So we want our region to be to be 0 and 2 pi. In terms of fourths, that would be 0 and 8/4 pi. So therefore, there are some angles that are outside of that. Well, clearly that's a negative angle. We want to be positive angle, so that one's out, and that one's too big. So here's our only solutions here. So the moral of the story is that when your period is made smaller and you're adding and subtracting an angle, so therefore your whole function gets shifted left or right, you want to add 2 pi a couple of times, and then you also want to subtract 2 pi once or twice, just to make sure that you get all the appropriate solutions. So to be on the safe side, I probably should have subtracted 2 pi again, but I kind of knew that since I was only changing it by down here by adding by pi over 2, that that's not going to make it close enough to hit a positive angle. So if this had been bigger than pi over 2, like let's say pi, then that would have worked out, or even 3 pi over 2, then this angle would have worked out. So if this is a rather small angle, it's probably not that necessary to subtract, but if this is bigger than pi over 2, you might want to actually do some subtracting of 2 pi from your original angle between 0 and 2 pi. Okay, so here we have tan equal negative radical 3. That's equal to when, I don't know, 2 pi thirds and 5 pi thirds. And I'm going to find the coterminal angles, so I'm going to add 2 pi to both of these, which is the same as, in terms of thirds, 2 pi, that would be 6/3. So I'm going to add 2 pi to both of those, and I get 8/3 pi, and add 2 pi to that is 11/3 pi, and then I want to do the same thing again since it's 3 theta. I'm going to add 6/3 pi. I like just to use black. So that's 14/3 pi, and that's 17/3 pi. And then also off that, going this direction, I'm going to subtract 2 pi, where 2 pi is the same as negative 6/3. So the angles I'm going to get if I subtract, I get negative 4/3 pi and negative pi over 3. So I now have 3 theta plus pi over 3 is equal to these 1, 2, 3, 4, 5, 6, 7, 8 angles. So I'm just going to do the negative one, so that's negative 4/3 pi, negative pi over 3, 2 pi thirds, 5 pi thirds, 8/3 pi, 11/3 pi, 14/3 pi, 17/3. Oh, we ran out of room there. So I'm going to subtract pi over 3 from all of these angles, because I have a positive pi over 3 here. So when I subtract those, I get negative 5/3 pi, negative 2/3 pi, pi over 3, 4 pi thirds, 7 pi thirds, 10/3 pi, 13/3 pi, and 16/3 pi. So now I'm just left with 3 theta is equal to these angles here. So I need to multiply all of them by 1/3, and multiplying this by 1/3 just gives me theta. So I have theta equals negative 5 pi ninths, negative 2 ninths pi, pi ninths, 4 pi ninths, 7 pi ninths, 10 ninths. Okay, 13 ninths pi and 16 ninths pi. So now we just make sure that all of our angles are in between 0 and 2 pi, where I'm going to write 2 pi as 18 ninths pi since all my denominators are in ninths. Since 0 is positive, and I don't want to include 18 ninths because that. So I'm going to put a open parentheses there because I don't want to include 18 ninths because that'd be coterminal with 0. So since we don't want any angles outside of that interval, this is negative, clearly outside of there, and negative as well. These are all fine. 4 ninths, 10 ninths, 18 ninths is as big as I want. 16 ninths is less than 18 ninths, so therefore there's my answers. So now we have theta over 2. So theta over 2, as opposed to making more solutions, there's actually going to be less solutions. Because it ends up, if this is the graph of cosine, it ends at 2 pi. If we graph, let's use this color, theta over 2, that's going to double it. So therefore, we're going to reach the halfway point here. So we're going to cross here. So it's going to go something like this, where this is 4 pi. So it looks like we're only going to have one solution when cosine is equal to a half. Now we have to keep in mind that we're subtracting pi over 4, so we might want to consider some coterminal angles when we're doing the calculation. So cosine equals a half at pi thirds and 5 pi thirds. Let's just add 2 pi to pi over 3. So if I add that, that would be, let me write that out. So if we add 2 pi in terms of 6, that would be 6 thirds pi. So that would be 7 thirds pi. I wanted to do that in black. Seven thirds pi and 11 thirds pi. I'm pretty sure this one is of no use. And then let's also subtract off this way. Let's do negative 6 thirds pi. So that's going to be pi thirds minus 6 pi thirds is negative 5 thirds pi, and that's negative pi over 3. So we now have theta over 2 minus pi over 4 is equal to pi thirds, 5 pi thirds, which is probably no good, 7 pi thirds, 11 thirds pi, negative 5 thirds pi, and negative pi over 3. So we need to add pi 4s to both sides. So our common denominator here will be 12. So I'm just going to rewrite these all in terms of 12s off camera. So I wrote all these angles in 12ths, and then I wrote pi over 4 as 3 pi 12ths. I'm now going to add 3 pi 12ths to all of these angles here, so I'll just do that off camera. So all of these angles are equal to, so I got rid of the pi over 4, I now have theta over 2. So I'm now going to multiply everything by 2. So all these 12s are just going to turn into 6s there. So I'm just going to do that off camera. Okay, so as you can see, we can eliminate most of these because our interval is from 0 to 6ths, would be 12 over 6 pi. So therefore this is too big, too big, too big, too negative, too negative. So notice our only solution is 7 pi over 6. So when you're dividing by, it stretches out the function so much that you only have one solution, you don't have additional solutions. So I did a lot of extra work that I didn't need to do.